Availability is a very important aspect of modern system designs because there's a lot of information exchange and a lot of business depends on the software. So in very simple terms, what availability means is if uh, you're able to use a software product and it is working efficiently without any failures, that means the system is available. The practical example if is that you use a Paytm app, you're able to do the transaction. Now the functionality is intact. It means that amount is debited from your account, amount is credited to the merchant account, and you get a success response. So it means you're able to complete the transaction and the overall functionality of the product or the software is intact. It means that the system is available in a very simple terms. So why availability matters? As I said, a lot of businesses today belong or directly depends on the software it runs into. So if the software is not available, it means the user is not able to use the product. There is direct loss to the company. For example, someone is using PayPal and if to do the transaction, and for some reason the PayPal app is not working, it means the PayPal app is unavailable for that time. For that time, user is not using that app and he might go to some other app to the transaction. So it means the PayPal is losing the business for that amount of time. So it means there is a direct business impact from the availability. So that is because it becomes very important in today's software systems that they are highly available. In monetary terms, it could result in like $7,000 per minute of loss to the business. This data is taken from like multiple outages which has been happening to uh, big software system companies like Amazon, Facebook, Google. So there's a direct impact of availability to the business. Now, before understand, create an understanding of how to create highly available systems, we should understand the problem. Uh, what are the basic reasons of low availability of a system? One is hardware failure. So let's say you are using a Paytm, right, and it's deployed on a single server. Let's say it is server 1, this is a Paytm server. So user 1 is coming and doing the transaction, right? If for some reason this hardware is down or this node is down due to some hardware failures or there is some security patch happening, it means the user 1, whatever request of user 1 is going to the server 1, it will get a bad response, right? Some 4xx. So it means for that amount of time your Paytm app is not available. Since this whole application was deployed on a single server, so there was a single point of failure, right? So in such cases, even for a small fault in hardware on a single node, your whole app is become unavailable. So that is one of the reason of low availability. Software bugs. So if you release something new and introduced a software bug into your system, that might return a bad response to the user. So that is also a reason of low availability. So it becomes very important to deploy a code after doing a thorough testing, which is like a manual testing or maybe some sort of automated testing, right? In terms of unit test, end-to-end tests, and performance test. So that might also, software bug is also one of the reason of low availability. So you also always ensure that whatever code you're releasing is being tested thoroughly. Dependent service outages. So this is again an interesting part. So let's try to understand what it means. So let's take an example of the Paytm app itself and try to understand how the dependent service outages impacts the availability of the software itself. So when you use Paytm, right, to do a transaction, what it does is, it's what is the functionality? It's debit the amount, credit amount, and success response, right? So taking this in mind, let's assume you have a user A, user B, which is a merchant, and user A is doing a transaction through Paytm, and his bank account is, let's say, ICICI, and user B bank account is SDFC. So when you're doing a transaction through Paytm, right, which is just an interface, what it does in backend, it connect to ICICI Bank servers where they have APIs to connect with, debit the account from there, then it connects to HDFC servers, credit the amount to their servers, and then it returns a success response and send a notification to user B. So there is sort of step 1, 2, 3, 4, 5. So it may happen that Paytm as an application is working fine. There is no sort of issues in the Paytm app, but its downstreams for which it is dependent on to work completely, they are down. For example, in this case, ICICI Bank servers are down, or SDFC Bank servers are down. In that case, it cannot complete the transaction, right? So in that case, even there is no fault at Paytm side, but the services depends on has some issues. So in that case, your Paytm also becomes unavailable, right? So that is why dependent services outages is also one of the reason that your system might become unavailable. Another issue is the uh, request overload. What it means is that, say, for example, your Paytm servers are able to handle 1,000 requests, but somehow the the requests are increased to 10,000 per second. So in that case, 9,000 requests will be rejected. So basically, your Paytm product would be unavailable for 9,000 users, right? So let's say its capacity is 100 requests per second, and suddenly there is a lot of increase in traffic. It goes to 1,000 requests per second. So for the 900 users, it will send uh, it will throttle the request and send um, the empty response, bad response, you would say. So in that case, for 900 users, system is unavailable. So these are some of the reasons why your system has low availability. Let's try to understand how you can increase the availability of your systems, right? So one is failover systems. What does it mean? Let's try to understand. So one of the reasons of low availability is you have a single point of failure. So let's take this example. Suppose you just have an active server, you just have this server one, which is taking all the traffic, and suddenly it goes down. So there is no backup server or application server who can take the traffic now. So all the requests will be failing, right? So in that case, there is no failover to your systems. So that is where failover comes into a picture. So you always create sort of redundancy into your system, and you don't have a dependency on single hardware for overall your system to work on. So in this example, if you see, this is sort of an active passive distribution. So where you have a request on server 1, but you will always have server 2 ready as a backup. So if uh, there is some issues with the server 1, the traffic will start going to server 2. So overall, there will be some uh, unavailability for couple of seconds because it will take some time to switch to the backup server, but still your system will recover very soon. So this is sort of a failover mechanism you have whenever you face some issues with the hardware. You redirect your traffic to a different server which is available as a standby. So this is called a active passive failover. So the disadvantages with this is like you would need some sort of a delay to switch over to the backup server. So for that amount of time, your system is unavailable for, let's say, it's order of like some seconds, maybe 2 to 3 seconds. So for that, you have sort of a active cluster where all the requests from the clients will be going to the load balancer. They will distribute the request to different servers, and the distribution would be sort of either round robin or weighted or maybe a different algorithm, but it will ensure that your overall functionality is not dependent on one machine. So you could have like multiple nodes where your load balancer is sending these requests. So even in case this server is down, you have other servers who can still serve the request, and your system is available, right? So this is kind of active cluster. So in most of the configurations which the highly scalable system use, they have an active configuration where behind the load balancer there is a fleet of servers which can take the request, and if even number of servers are down, the overall system is still available because there are a lot of other systems um, which can take the traffic. So these systems continuously keep on sending the heartbeats or some signals to the load balancer that we are alive. If the load balancer doesn't receive such signal, it means that the server is down and it doesn't route the traffic to that server. So that is how like the load balancer and these nodes keep on connecting with each other or communicate with each other. Another pattern is you have sort of a single point of failure on the database side. So what you have is you have multiple nodes at the application layer where your load balancer is sending those requests to different application server, but when they're interacting with database, we just have one server, or which is shared between all the servers. Now what will happen if this database is down, right? Your whole system becomes unavailable, right? So there is again a single point of failure. This time it is not at the application layer side but at the database side. So how this is usually handled, you have like multiple sort of database servers. Your whole system is not depending on single server, database server. It has multiple data servers, and the request keeps on going to different data servers. So after application layer, there is load balancer between your application layer and your database layer, and the load balancer will distribute these requests to different databases, right? And the data between these servers are getting synchronized by having like an application. So if you're writing something here in this db1, there would be automatic replication happening and the data would be replicated to db2. So in some cases, if this db2 is down, the load balancer will redirect all the traffic to db1 and it will have all the data because the data is already replicated. So in that case, uh, you are ensuring that you are not depending on single database server. You always have some backups or redundancy created in the system, so that even in worst case your system is available. So whatever we just discussed is called a failover system, that you always ensure, so if your system fails there is some other node to take over. Clustering is also on the similar lines, where what it means is that the application layer, you are not depending on a single application server, but it's a cluster and there are a lot of hardware nodes in between. Backups is again very important, so all the data which you are storing in your database servers, you back it up into some other resources as well, other database servers. So even though if both of the database is down, you would have a different backup server which is have all the data. So usually we keep on taking the periodic backups, like every minute or every day based on your business requirements. Geographic redundancy. So this is again very important. Let's try to understand what it means. So when you say your database server, it means that somewhere it is physically present. So let's say it is present in Mumbai, right? So there are database servers, physical database servers available in some data center of Mumbai. Now what happens is, let's say there is a natural disaster happening and there is no power supply to these data centers. So in that case, your application cannot connect to these databases because there is no power supply and there is no internet, right? So in that case, your whole application become down. So what is advisable is you always create a redundancy and have the copy of your data into multiple geography. So you have that in one in US zone, you have a copy of your data in Europe zone, and any sort of change in data is replicated to these other data centers as well. So that is where this becomes very handy in terms of geographic redundancy.